There are quite a number of things we can do as an individual to improve the code quality, and that's what we're going to talk about in this presentation. Sure, we can all say that we would improve quality if only the team we work in really cared about it. And to a great extent, that may actually be true. But there are so many things that we actually can do as individuals to improve the quality of code. After all, if every person on the team doesn't really do their share, how could we expect collectively as a team to really improve? So we want to really address the problem at individual level, and then we will talk about what we can do at the team level collectively as several people on the team. So let's take responsibility for code quality as an individual. There are so many things we can do. Often we overlook it, not because we don't care about code quality, it's because we don't even think about it. And if we really spend a little bit of time thinking about every little activity we perform, there are so many ways we can actually improve the quality of code. The very first thing I would recommend is care about the design of the code we are creating. There are so many things we actually can do as programmers, as individuals, when creating code that sometimes become sloppy. Again, not because we don't care, it's because we don't even think about it and the effect that it may actually have. Come on, let's think about this. How many times have you worked on projects where programmers have used single letter variable names? We see this quite often. I'm not talking about those index variables and loops where there are clearly variables that can use better variable names, and yet people have used variables like X, Y, Z, A, P, Q, and L. Now, to me, that is professional irresponsibility, right? We really need to be more responsible in and take responsibility for things, and we need nobody's permission to act professional. It is our ingrained responsibility for us to be able to do that. So the very first thing I would ask for is, let's start giving good variable names as we are writing variables. I know I'm as much at fault as anybody else is. It's so much easier to give a cryptic variable name. Why? Because it feels good, isn't it? So we kind of give a cryptic variable name. We call it LST. And I've done this quite a few times. But LST or even the word list really doesn't mean anything. What is this really representing? Is it a list of names, list of friends, list of temperatures, list of prices? Give it a good domain-specific variable name, not necessarily a very long name. Long names doesn't make it better names as much as short and cryptic names make it better names. Give a good variable name. And sure, sometimes we can come up with a good variable name. Somebody else looking at the code says, yeah, I don't really get it. That's perfectly fine. At least we tried giving a good variable name, and then we can evolve it. But if we give a poor variable name, we failed at it in the beginning itself. So give good variable names. Is it a temperature in degree Fahrenheit? Maybe we could say temperature in degree Fahrenheit. Or is it distance in miles? Maybe we can call it distance in miles rather than calling them as T and D respectively. So we can give better variable names, and also we could say current balance maybe rather than saying bal as a variable name. So we can go ahead and give good variable names, meaningful variable names that quickly relates to the programmer what this is really talking about. After all, a code is being written for programmers to read and understand, and not really for machines to understand, because machines can understand a lot of garbage we provide to it, but we programmers need context and help to really understand it. Write short methods. Whose permission do you need to write short methods? We can write short methods, and again, short methods doesn't mean the methods are really small. More important, the methods really focus on a single level of abstraction. So if we can focus the methods on a single level of abstraction, the method doesn't tend to become too long, and we can modularize it. And there's so many benefits of having short methods, and we can benefit from some of those advantages, and by providing short methods. Similarly, writing smaller classes. How many times have we come across methods that are 3,000 lines long and classes that are 10,000 lines long? We can create smaller classes, focus on the single abstraction and single responsibility principle, and try to focus on doing one thing and one thing well in these classes. One of the ways we can actually improve on this is by reading really good quality code. Most of us have seen so many bad quality code, we may not even realize how a good quality code could actually look like. So if anytime you come across a good quality code, don't keep it quiet. Make a noise, show it to other people, especially if it's other people's code. Show it to other people and say, hey, look, I was looking at Joe's code here, and look at how beautiful this code is, and over here is Jane's code. Look at how wonderfully she has written this particular class, and share what you like about other people's code so we can promote better quality code among people. And that's a better way to bring together and foster better quality by helping other people learn and ourselves learn from good quality code rather than staring at poor quality code all the time. So these are things we can do as an individual without any really mandate or support from the team. Nobody can stop you from sharing your opinion about good quality code and say, hey, look what I found. This is really exciting. Print out a good quality code and post it on your wall. So if somebody else comes along, they can look at it. It can also serve as a motivation for yourself as well. Or blog about it. You look at a quality of code elsewhere. Maybe you're looking at an open source project or somebody else's project. You look at something and you really like it, blog it and say, hey, came across this code and I really like it, and here are the reasons why I like it. And that's something we can also promote and motivate ourselves to write better quality code. So there are things we can do. Keep it simple, the KISS principle. Keep it simple and stupid. So the point really is, we don't want to unnecessarily complicate code. Again, this is something we can do as an individual. Avoid the temptation to build complexity and instead focus on creating something that's relatively simple. Rather than trying to make the code extensible when we don't even understand what this code is supposed to do, we could create the code with minimalism, doing exactly what we know we should do right now, and only caring for extensibility to the extent we know about it, and not make it overly complex and overly extensible. Reduce code, remove things that are not necessary, and try to aim for simplicity. And clarity in code as well is something we could strive to create. Write automated tests with high code coverage. Now, I'm a huge fan of code coverage. I'll talk about code coverage in another presentation, but I believe in creating code with a lot of good coverage. And the reason is that we can ensure that when we do modify the code, we get a fairly good feedback whether the code is actually broken or the code is still working as expected as we wrote it earlier. So automated tests with good coverage help us to make sure not only that the code once worked, but the code continues to work as we make changes to the code, and that is very beneficial as well. So try to aim for high coverage. First of all, write automated tests. And if we make it a practice that we consider untested code as unfinished code, then we would write tests and make sure we leave those tests as automated, not just run the test once, but have those tests run every time the code is modified and checked in. We can then aim for a fairly good coverage from the code, and we can use that feedback cycle. And before you check in the code, would you dare to check in code that doesn't even compile? Not really, right? You would make sure the code is compiled and the code actually has no compilation errors before you check in. But let's go a step further. Let's make sure that tests actually pass before we check in the code. Now, It's always fun to be running the test from the IDEs, but if we can have an automated script, like in a continuous integration setting, and we can run the same script on our machine before we check in the code, then we can eliminate the possibility of, oh, I forgot to run these other tests. Of course, for this, we want to make sure the test actually run really quickly. And if you have integration tests that take hours to run, it is meaningless to say that make sure all those tests pass before you check in the code. But we can categorize the test into fast running tests that give us quick feedback, hopefully meaningful fast running tests that give us quick feedback, and maybe long running integration tests that we don't run on our machine before we check in the code because those feedback cycles are slow, but we can run meaningful fast running tests every time before we check in code. And also avoid cargo cult. I see cargo cult in a lot of us when we look at some practice and we say, oh, I really like this practice, I'm going to use it, without really understanding why that practice actually exists and how that practice actually helps. If we understand why a practice really helps and it exists, then we would make a decision as to whether those practices are meaningful for what we do and pick and choose practices that actually make sense. So avoid the cargo cult practice where we follow a practice because we see that it's somebody else has used it and they are relatively successful, so whatever they do should be useful for us, but instead only use practices that you understand and apply practices that will directly benefit for our own project. That's very important. And code feedback and criticism. This is something we have to have the desire to do. If I do not feel comfortable asking other people's help, then obviously I don't get that feedback or the benefit from the feedback. So we have to build in ourselves the particular desire to really improve ourselves by getting feedback. Walking over to a respectable programmer and say, hey, I know you're busy, but I know that we all write good code, but we also from time to time write poor code and we can improve. I'm wondering if you would be willing to, kindly look at my code and give feedback on how I can improve in a very constructive manner so I can actually get to become a better programmer. You are writing really good code, I see it, and I can benefit from some of those knowledge as well. Would you be willing to look at my code and give feedback? So ask for feedback and court this feedback and criticism and ask people to criticize in a healthy way so we can actually improve. I know I've seen teams where this happens. I've also come across teams where programmers are fearful or are ashamed of asking for feedback. We need to break that culture. We'll talk a little bit about this when it comes to team's effort, but it's something we need to work on as an individual as well. And maybe we can find one or two people that we are comfortable with, and we can ask feedback from them and improve on the quality of code. And one of the other ways we can improve code is by checking in the code frequently. Now, this is a bit of a controversial topic. I know people differ in opinions about this, but what happens if we don't check in code for a long time? If I've not checked in code for a long time, and if I think there is a way to improve the code, I'm fearful to make that change because I don't want to break everything that actually works. But if I check in the code, I can quickly make a change. If the change works, I can keep it. If it doesn't work, I can throw it away and get the code from the version control and move on. This is especially very easy if you're using tools like Git, because we can check in frequently locally and then we can decide when to push it to the remote server. So there's absolutely no reason for us to check in code anytime a small piece of code works and the test related to it is passing. By checking in code frequently, it gives us the courage to really make change and improve the code much more than if we have not checked in code. And if you are thinking about improvement that comes along in your mind, if you have the code checked in, you quickly try that improvement. If it works, that gives you the ability to keep that code and move forward, check in and move on. Otherwise, discard the most recent improvement you try to make, get back the code and try another improvement that you may have in mind, or move on to the next task. By checking in code, there's another big benefit. If we check in code frequently, it can, and in this case I'm talking about pushing it to the server, it can give opportunity for other people to quickly integrate with our code and also give feedback very quickly. And if we're making a fairly good amount of code development and refactoring, we want to get it out in the hands of other people sooner than later and get that feedback very quickly. It takes a bit of a courage to really be comfortable to get the code out rather than hoarding the code. And sometimes we want to improve the code, and the improvement we think in our mind is really not the improvement that actually can help. So it is something we have to work really hard to get this practice under our belt to check in code frequently. I was mentioning this the other day to somebody, and they asked me how many times I check in the code, and we quickly looked at my version control, and there were hundreds and hundreds of check-in in a day. And I do firmly believe in this. To check in code very frequently and get the feedback from that is very important. Like I said, it also gives me the ability to make changes more freely and courageously, rather than not checking in the code and hoarding it. So we can improve the quality of code quite a bit as individuals by starting with caring about the design, creating good variables, writing short methods and smaller classes, and by reading and sharing about other pieces of good code we come across, by keeping things simple as possible, writing automated tests with high code coverage, and running the tests before checking in the code, at least the meaningful fast running tests before we check in the code, avoiding the cargo cult and using meaningful practices to have the courage to code feedback and criticism, and to check in code very frequently, or things that we don't need anybody's permission. We can work really hard to make these things happen to improve the quality of code.